Hi all, we are back with another video lesson. I am open to suggestions on like an intro song or like a sign off. So let me know, since this will be kind of like what we do. It might be kind of fun. Anywho, just gotta spice it up, right? To make these things not seem so daunting. But we are in our notes packet. So the next lesson that you haven't done in your notes is called sketching intersections, but we're going to skip that. So skip this page that looks like this in your notes packet, and you should be on this one here that's titled segments and their measure. So this is the notes that you're doing. So make sure you're on the page that looks like this. Okay, you might want to have a calculator handy. We'll do some kind of more calculations today than we have in the past. So that might be useful for you. And we're going to get started, okay? So segments and their measure. So after today, we're going to be able to find out how long a segment is. We'll be able to solve for variables in a situation that involves segments. It's kind of exciting stuff. It's kind of like more geometry with a little bit of algebra sprinkled in. It's a good time. So let's just dive in right here. So it says, using a number line, the distance from C to D is written as blank. So when we talk about the measure of a segment, so let's, back up a second. A segment, remember, has a starting point and a stopping point. So I could call this GH. Remember, that's segment GH, because it starts and it stops. And since it starts and it stops, we can actually find out how long it is. So if we go back to our question here, it says, the distance from C to D is written as CD. So this time we don't have that segment bar on top like we did up here when we talk about the measure. I know that's kind of goofy. It's just like one of those mathematical notation things that we just need to accept. It's kind of like you always capitalize the first letter of a sentence. When we talk about the measure of a segment, we don't have the bar on top, okay? This is also called the length, how long it is. So let's actually find out what that is. So if I want to find out how far it is from C to D, we just count on a number line. I like to do the bunny hop thing or the Frogger thing. So there's 1, 2, 3. So CD is 3 units long. Well, what did we do? Well, you could count the spaces. You could do the bunny hop. I think the easiest thing to do is I'm going to say count spaces. Because a lot of us will count the tick marks, and that will give you the wrong answer. You want to count the actual gaps. We have 3 gaps between C and D, so it's 3 units long. Okay, you guys take a second. You find the length of AC here and AB. Ready? Go. Okay, let's find AC. So I'm going to count the spaces or do the little bunny hop. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9. Did you guys get 9? 9 units long. And then now we can count for AB. I'm going to go underneath so I don't confuse it with the top ones. Ready? 1, 2, 3. I got 4. What did you guys get? 4? I hope. Okay. Good deal. So when we have a number line like this, very simple, very easy to find out how long a segment actually is. Okay, I'm going to shimmy my notes up a bit. That should be perfect, somewhere right there. Okay. So between, when we have 3 points on a line, one of them is between the other 2. Well, duh. So in this situation here, do you guys see how A, B, and C are all on this line? So clearly one of these points is between the other 2. So do you guys see how B is between A and C? That's all this is saying. What's nice about this is we can break now our segment AC up to different parts. So AC is how long the whole thing is, right? From here to here. That's the whole thing. But when you have a point that's between those two endpoints, we can break it up, and sometimes that will help us solve problems. So look right here. I could break it up into this chunk right here, AB. So I'm going to say equals AB plus, now what's the other part? Like what's this chunk here? You're right. It's BC. And what we just did there is we call that the segment addition. It's when you have a segment, so AC, right? That's my big segment. And then I break it up into its two parts. And doesn't that make sense that AB plus BC gives me the whole thing? Okay, let's try some problems. So it says, do we add or subtract? Well, let's find out. So our goal is to figure out what EF is. So I want to figure out this guy right here. That's our job. So what are we going to do between 16 and 10? What does 16 represent? 16 represents the distance from D to F. Okay. And 10 represents from D to E. So am I going to add 16 and 10 to find this missing part or subtract? We're going to subtract, right? Because the whole thing is 16. And I know up to here is 10. So what's left over? Let's see here. 16 minus 10 gives us 6. I'll write that right here again. 16 minus 10 equals 6. Okay, you guys try the next one. We're looking for A to C. That's what we're trying to find. How am I going to figure out how far it is from A to C? You're right. We're going to add. I have to take 14 plus 6 more. 14 plus 6 more gives us 20. Woo, woo, woo. Good job. Okay, so when it's pretty basic math like that, it's not so bad. But then we like to jazz things up and throw a little algebra at you. So I'm going to take this away. And now your note sheet should look like this, I hope. I know I didn't give you a ton of space to write, so I apologize, but do the best you can. Okay, so we're going to use that whole idea of breaking up our segment into parts that we know to find missing pieces. So it says use segment addition, and we're told that MP, so the length of the whole thing, is equal to 4x minus 10. And our job is to find all of these different pieces. Hoofda. So let's break this down a bit, okay? So what's the whole thing? Well, the whole thing is MP. So I'm gonna write up here. Maybe we'll have a little more space if we write it up here. I'm gonna say MP equals what two parts added together? Well, MN plus NP. Right? This long guy is equal to this little piece plus this one. But now what's nice, guys, we can just plug in. Well, what does MP equal? Well, MP equals 4x minus 10. So I'm going to plug that in. And MN equals what? X minus 4, right? They're telling us that this chunk here equals x minus 4. And then we want to figure out what NP is. Again, they're being nice. They're giving us a lot of information. We know that NP is 2x plus 3. And now from here, it's just algebra. We just need to simplify and figure out what x is. We can't do anything with this left-hand side yet, so let's just copy it down, and then we'll worry about that in a minute. But over here, we have some like terms we can add together. And I know you guys can do this. We did this last week together. I have an x and a 2x for a total of 3 x's. And then -4 plus 3. -4 plus 3 is -1. So now we have variables on both sides of our equation. So I want to get my variables to one side and the numbers to the other to solve. So I'm first going to subtract over my 3x minus 3x. Okay, I'm going to come down here. Is that all right? So 4x minus 3x is just x. I need that to be minus. Okay, so I'm going to wriggle. So x minus 10 equals -1. So that's what I have left from there. Then I'm going to add 10, add 10. So then we are left with x equals -1 plus 10 gives us 9. All right, we did it. We just found that x equals 9. And now we're going to go in and figure out what these are. So MP, we're just going to plug in. So MP is this little expression here. So 4x minus 10. So I'm going to have 4, but instead of writing x, I'm going to plug in 9 since that's what x equals. So 4 times 9 is 36 minus 10. 36 minus 10 is 26. So that's one answer. MN, we're plugging in right here. 9 minus 4, 5. And then our last one, NP, we're plugging in. So 2 times 9 plus 3. 2 times 9, 18. 18 plus 3 equals 21. And you guys know why math is like one of my favorite, well, is my favorite opposed to other subjects, is a lot of times we can check our answers where I know in some of your other classes, you can't check to see if you're doing things right. But a lot of times in math, we can. So we're kind of the lucky ones. In this example, we can check. So let's just see here. They told, or we found out that the whole thing equals 26. So I'm going to write 26. And then we found that MN equals 5 and NP equals 21. Well, let's check here. What's 5 plus 21? I got to be 26. And is that what we wanted it to equal? Yeah. So it checks out. So I know we did it right. Isn't that kind of nice to know you did it right? So like on a quiz or test or even your homework, you can check to know if you're on the right page. I don't know about you, but that makes me feel good when I do my homework or things that if I'm doing it right or not. Okay, we will do much, much more work with these when we're together in class. So if this was confusing, that's okay. It probably will be or should be. But know that when I see you next in class, we will do a ton of problems like this so we become very comfortable. And then we're going to end our lesson on talking about congruence. So congruence, it's kind of like they're equal. Like if something's congruent to something, they're the same. They're equal. We have a special symbol when we talk about congruence. It's an equal sign with a little squiggle on top. This is a congruent symbol. In geometry, segments are congruent if their lengths are the same. Oops, I won't miss the word the. Are the same. So if I have a segment that's 6 units and I have another segment that's 6 units, those two segments are the same, or are congruent because their measures are the same. A lot of times in our class, you're just going to be given a diagram with not a ton of instructions or information, but we're going to learn how to read a diagram. So in a diagram, if there are short tick marks on two segments, we know they're congruent. So let's say AB had one tick mark and CD had one tick mark. If I was just given a picture like this, I would know these two segments are congruent because of those tick marks. And then this is where we get a little technical because we can. If I want to talk about the lengths of these two segments, I would say AB is equal to CD. Okay, kind of goofy. But then if I want to talk about them being congruent, like the actual segments are congruent, I would say segment AB is congruent to segment CD. So when I talk about their measures are equal. When I talk about the actual segment, that the physical segment itself, those things are congruent. So that's why we write them differently. Equal sign, there's no bar on top. A congruent symbol, we would have the bar on top. I'm not going to get too bent out of shape about this because it's just kind of like a small technicality, but just in case you wanted to know, that's the difference. Okay, folks, the last question I'm going to ask you today, it says which segments are congruent? So basically, out of these three, two of them are congruent and one's just kind of not, right? So what you need to do is you need to figure out if their measures are the same. So if I were you, I would count and figure out how long each segment is and go from there. So pause the video so then we can come back and check your answer with mine. Okay, so if I want to find the length of AB, I'm going to count the spaces. So 1, 2, 3, 4. If I want to find the length of CD, 1, 2, 3, 4, 5. So right now I can already tell you these two aren't congruent because they have different measures. So really EF is going to match either AB or CD. So EF, 1, 2, 3, 4, 5. Okay, so looky. I see two matching measures. So then I would know that segment CD is congruent to segment EF. Okay, we made it. Good job. I will see you next time in class and enjoy the rest of your day, you guys. We'll see you soon.